If there are no responses, I assume there are no issues during your tutorial or assignments. Well, that is cool, but if you do have any issues, just tell us immediately. Okay, now it's ready. Okay, I think I can start the class now. So, yep. So we will continue about the data delivery, which is the topic about your tutorial last week. And we will start, we will do a bit review on the history of the web itself. So you have been using web browsers, and I'm sure that most of your daily life are now assisted by the help of web application and mobile application as well. But this is only possible when the US governments created what is called as the internet, and then it is used for public so that they can share information to the others through this internet platform. But since we are currently learning about web development, we don't really, we will not cover the actual history of the internet. That will be covered when you take the computer network course. But for the web itself, it actually started around early 90s, where there is this smart guy, Tim Berners-Lee. He developed what is used for building the modern internet today. So he is the one that devised the HTML standard and how to address resources that is shared via the internet, and also the protocol that lets multiple computers to communicate with each other through the internet. So the first web page was created by Tim Berners-Lee in 1991, and it is still online. So you can check in the link on the slide there. You can see the first web page that Tim Berners-Lee created is like that. So it's pretty simple. And I think we can check it directly. And we can also check the source code. So if you are using Google Chrome or Brave or Microsoft Edge, you can use Ctrl+U shortcut to see the source code of an HTML page. And if you see the source code of the first web page created by Tim Berners-Lee in 1991, you will see some similarity to the HTML code you write in 2022. But yeah, there will be some differences because it's already like 30 years since Tim Berners-Lee wrote this page. For example, there is the HTML document is not contained within the HTML tag, right? In your first and second tutorial, you were told that to create an HTML page, you have to put the pages in between the HTML text. But in this example, Tim Berners-Lee didn't put any HTML text there. He just put the actual text related to the content of the page. And there's a tag that is not familiar anymore in the current HTML standard, like next ID, but the others are pretty much still the same, like the anchor tag, the heading tag, and also, yeah, DT and DD still works, but I think we rarely use this pair of tags, DT and DD. But you can see that the HTML pages written in 90s are still similar to the one that you will create in 2022. So that's the first web page created by Tim Berners-Lee in 1991. And yeah, some interesting things mentioned in the document is about the terms about hypermedia. So Tim Berners-Lee, I'm sorry if this is going to be a bit of history lesson. This is quite my personal hobby actually. Nah, to cover history or looking at videos related to history. So Tim Berners-Lee mentioned about the hypermedia here. And if you remember, the H in HTML, in the HTML stands for hypertext. Wait. So Tim Berners-Lee mentioned this concept of hypermedia or hypertext. He proposed that the content that is delivered via the internet through the World Wide Web should be interconnected to other contents in the internet. Hence the terms he created, the hypermedia or hypertext, because he wanted that the information that created on the internet can link it to other informations. Well, in the HTML, we can do that by using the anchor text mechanism. We can put a link to another document or a link to another website. That's the concept of interconnectivity of documents through the hypertext or the hypermedia. But we will see later in subsequent slides that this vision is currently a bit distorted by the modern landscape of the internet. Clear? Okay. And yeah, if you really want to experience what the web, how people in the 90s browse a website, you can also check that site that I put in the slide. It is a browser within a browser, so you can open the first HTML document written by Tim Berners-Lee using this browser in a browser. But yeah, since it is only a simulator, it can only browse the pages that already bundled in the browser. And yeah, a bit more about history. In the 90s, pretty much most of the pages are written in text. And considering the technology, the state of the art back then, yeah, the connection is still pretty slow. Was pretty slow. I remember in 1997 or 1998, the modem, the thing that you use to connect to the internet, the maximum bandwidth or the speed is capped at 56 kilobit per second. So it's pretty slow compared to what we have today. Like, probably your internet connection at home is have bandwidth set to 10 megabits per second or 100 megabits per second. So the comparison is very contrast if compared to the 90s. And then some improvements in the HTML standard. The web developer can perform what's called as asynchronous operations. So by using a JavaScript, a client-side programming language, the web developers can include a dynamic functionality where the web page in the web browser can run a piece of code, and that piece of code potentially can communicate with the server in order to return a new data to be displayed in the web browser. So it can perform what is called as asynchronous operation. So the code running in the web browser can run possibly in interval or continuously to obtain new data to be displayed in the web browser, and also to respond for further user interaction happening in the web browser. And then the HTML standard developed further. Now we have HTML5, where not on the web pages are not only for displaying text and images, but now also the web pages can also display 3D models, or can be used to provide interface to 3D games as well. Because in the HTML 5.0, they introduced some new text such as canvas that lets you to have more features regarding to drawing an image into the web browser. But I have my own history of the web, the summary of it. So from the 90s, we have the first page written by Tim Berners-Lee, and then in the 2000s, Amazon is already exists back then, and they already selling products via the internet. But in the 2000s, there was an event called the .com bubble, where many investors look at this new trend called the internet, and they figured out that the internet is potentially useful and can be used to build commercial oriented websites. So they begin to invest on many platforms, on many websites. And eventually, since there are so much money put into the websites, there was a bubble or crash in the market that makes not almost, but many websites shut down because they run out of funding, because the nature of the market back then. And it might happen again in coming years, I don't know, but I don't really speculate on the market. So that was happened in 2000. And in 2006 or 7, social network become more popular, so people began joining MySpace, Friendster, or Facebook. And now, as I mentioned before, this is when things went differently from what Tim Berners-Lee envisioned back then in 90s. In the 90s, Tim Berners-Lee wanted that all of information in the internet can be interlinked with each other. But when the social media companies start popping up in 2006, 2007, and until now, most of the content or the information that created by the service provider and also the users who using the services begin to be locked down in each website. For example, if you try to open an Instagram page of somebody, maybe you follow an artist or a public figure through the Instagram, you can only view their posts or their photos if you have registered on Instagram. However, if you haven't registered on Instagram, you may be allowed to see some of the photos and then Instagram will ask you to log in to register into their website, or even some of the pages in the Instagram cannot be accessed unless you log in into the website or you have created an account in the website. So now we have websites that behave like a walled garden. They put gates they perform gatekeeping to not allowing users or not allowing the general public to access their website unless they have registered to their website. And by registering to their website, like you register on Instagram, TikTok, or Facebook, in a way, you have to comply with their rules. You have to submit some information into the service provider, whether the service provider is TikTok, Facebook, or Instagram. And consequently, you have to share data, your personal identifiable information to them, which can be used for their own personal benefits. Maybe they will sell your data to the advertiser company, or maybe they will generate a profile about your behavior. So yeah, that's the reality of the internet today. Although the vision is good, I mean, the vision devised by Berners-Lee back then was noble, but in reality, now it's being controlled by major players, major corporations in the internet. So what we have now is more like walled gardens of apps or websites. Okay, now back to the timeline. So in the 2010, we began to have more varieties in web browser. Usually back then, the web browsers are only Internet Explorer or Firefox. It already exists in 2007 or 8. Chrome was just still a beta version in 2008. But since the beginning of 2010s, we begin to have more varieties in web browser. And in 2017, we have this WebAssembly that lets you to have a binary code, like a program that's already been compiled to binary, and that program can be run in web browser. So web browser now not only able to read HTML, CSS, JavaScript, but now can also handle binary code that contains a program. And the consequence is we can have more methods in delivering not only information, but also program. So potentially in the future, we don't have to install any other application other than web browser, because everything can run in web browser eventually. But yeah, that's still in the future, and it is still not set in stone. So who knows? We will see later in few years later. And now we might have predicted that an image of monkey can have a word in internet. So now there is a thing called Web3, and it depends on your I don't know what it's called in English, but some people might be very optimistic with this technology called blockchain, but many others still pessimistic about them. So this will be controversial, but I'm just going to put this. There is a new concept called Web3 that calls for decentralization of the internet, because as I mentioned before, right now the internet has been like a collection of walled gardens, and the proponent of Web3 proposed that we should decentralize the internet. But while I agree, I'm sorry, this will be a bit of political. Okay, so while I agree with the sentiment, but I'm not really agree with the technology they use. Okay, so I'm a bit skeptical on blockchain, but I agree with the sentiment that we have to return to the original vision of the internet. Okay, so enough of the history lesson. So let's continue about the data delivery protocol. But before that, I want to ask you: is there any questions regarding the history of the internet, or maybe you want to ask something? Because I pretty much already lived my childhood until now familiar with the internet from the days where the internet was pretty slow, and until now we can basically just use our smartphone to connect to the internet. Anyone? Any two? Nobody? Maybe, yeah, your generation is what it's called as, I don't know what it's called. Is it Gen Y or Gen Z or generation whatever? But most likely you already born in the days where internet is already common. So maybe you're already using internet since your early childhood by maybe using your parents' smartphone or an old feature phone that already can connect to internet using GPRS internet connection. So you're already familiar with internet. So getting online 24/7 is already a nature or a norm for probably some of you. But yeah, back then we cannot online most of the time, so we did have time. We did have offline time where we didn't connect to the internet at all because there was no smartphone. Connection was pretty slow. So yeah, in a way, some people consider that a plus of having a more grounded life, not always connected to the internet. Okay, enough of the history. Let's continue with the data delivery. So maybe I want to draw you some illustration. But this illustration will kind of reviewing the concept of program. Okay, so let's say we have this model, and let's say I will draw a circle, and this circle represents a program. A program can be a program that you wrote in your foundational programming courses where it accepts input that typed by user and it will produce output via the terminal or the console. And every program will have input and then it will produce output. So that's the essence of program. And if we delve it deeper, yeah, program is basically a function, right? Or a collection of function, and a function will receive an input and will produce an output or will return an output. And that concept serves as the building blocks that will form into your program. Now, similarly, when you are developing a web application that access from the web browser, you can view it in this way. So your client here is a program, and the server is a program as well. Yeah, you can view it. Client is the web browser, and the server is your Django application. And in the client side, you provide input by clicking a button in your web browser, for example, or typing a URL. And the program, that is the web browser, will process that input and will produce an output. The output here is the HTTP request. So your client will produce the output called HTTP request or the request object. that is sent over the wire through the internet to the server, and server will accept that as the input, right? So when it reach your Django application, it goes to the project's urls.py and see whether this request object contain a URL pattern that match with the existing definition of the URL patterns in your project. And if it found match, it will be the processing of that request will be delegated to the correct application in the project. And then the function in the Django application will handle that. And eventually, it will do some data processing. And at the end, it will produce a HTTP response or response object. And that response object is the output of the program that is running on server, right? And then that same output will be sent to the client. And client will receive that response object and use it as the input to the program running in the client, that is the web browser. And yeah, that's one cycle of an interaction between your program running in the computer, which is your web server, which is your web browser, and the program running on the server, the Django application that you wrote. And yeah, I already explained this before. This one. So the communication between the client and server may happen in two approaches. First, it may happen synchronously, where for every request sent by user, then the user will wait for the response before the user can send another request. So, for example, if the user opened a website and then he wanted or she wanted to open another website, then he or she can only do that after he received the first web page. If he or she hasn't received the first web page, then they cannot open the second website. So yeah, it will involve waiting for the actual the response before the user can proceed to make another request. And there's also another approach called asynchronous communication. While it can use the similar example before, so the user requested for a web page, and that web page can send can be delivered to the user, and as I mentioned before, the web page may contain JavaScript codes or client-side codes that that will run in the user's web browser, and the code may requested another data from the server. So it's like if you watch a YouTube stream, a live stream on YouTube. In some live stream on YouTube, they have this chat box, right, that allows the watcher to send messages to the streamer, and the streamer may also read those messages sent from user. That mechanism actually one example of asynchronous data communication, because the chat box is running in parallel with the actual stream, and you as the watcher of that YouTube stream, you don't have to refresh your browser in order to check the latest chat messages, right? The chat messages are updated automatically because there is an asynchronous communication happening in the background of that YouTube stream. So maybe for every certain milliseconds, the web page will contact YouTube server to get the latest chat messages that haven't been sent to your web browser, or the other way around. The web server itself, the YouTube's application itself, push the messages into your web browser. That is possible by using a technology called WebSocket, but we won't cover that in this course. In the next upper level programming course, advanced programming, we might cover that technology about WebSocket. And yeah, so we have this request and response object, and for obvious reason, both request and response object must have a standard, right? Because the web browser and also the web server needs to know, not need to know, but needs to agree upon a commonly understood standard, so the application and the server can communicate with each other. It's like we have to speak the same language in order to communicate with other person, right? So if we want to speak with other Indonesian person, then we have to use Bahasa Indonesia, because most likely, like for most people living in Indonesia, usually they understand Bahasa Indonesia, Indonesian language. And if we want to communicate with someone else, like Japanese person or Chinese person, then we have to talk in their language as well. It's also similar in between digital technologies like web browser and web server. Server and client needs to have their common standard, so they can communicate with each other. And to facilitate that, there is this HTTP protocol. The protocol defines the mechanism of communication between two parties in HTTP protocol, and the parties here can involve the browser and server, or to be more general, it involves two programs that communicate using HTTP protocol. So that's the general definition of why HTTP is required, to allow two programs to communicate with each other using the HTTP protocol. But yeah, in this course we will use HTTP to make our web application can be accessed from the web server and from the web browser, and also to make our web application can be connected to by a mobile application using this HTTP protocol. So the content, maybe this is better if I use another software. So what I'm displaying here is a program called HTTPI. So usually when you access the internet, you use web browser, right? But in order to have a closer access, I don't know the correct English phrase for this, but in order to interact with web server by not using web browser, we can use this alternative client. Usually it's called as API client or REST API client, but to put it simply, it is a client that can send HTTP request and receive HTTP response from the web server. So let's check it. HTTPI.io. So we can check through this program the request sent to the URL here, and we can see that the request contains several attributes or fields. First, there is a field called host. Host usually contain the domain name, or not the domain name, but the URL that is requested by the client. So yeah, it's similar to the one that displayed in the slide. But yeah, it's more what is called more pretty. And based on this request, we can check the response sent from the given URL here. So after we send, oh sorry, I need to revise my explanation just now. So we have this get request, and the get request contain the path. /hello is the path, and that path is appended to the host contained in the request object, and the host is http/i.io. And there is this http/1.1. This is the protocol. So we are using protocol HTTP version 1.1 to send this get message to http/i.io. And user agent here is the descriptor that identifies the sender of the request. And this is inputted automatically by the client, that is the HTTP/I. And the response, we can see that it contains several informations like the length of the response. So the response contains the number of bytes that comprises of the full response object. And the response may also contain other informations like what is the name of the server application that serve this response back to the client. And then also there is a response code, that is the information that inform the status of the request processing, whether it has been successfully processed or the request cannot find the requested web pages and so on. Those information can be summarized in the response code. So there is a collection of response code in the internet. So if you open a site like PBP, yeah, this is a more visual way, a visual summarization of every HTTP response. So for example, if the response code is 2000, it means that the server was able to handle the request and able to return a response. But then there is also another response code. For example, the famous one, 404, not found. It indicates that the request that just sent to the server was not able to find the requested resource given the host and path to the resource. And another response code is usually 500, internal server error. This also signifies that there might be a problem with the maybe the server or even the application that runs in the server. And yeah, this information, or rather the signals, is put in the response object that is sent back to the client. And yeah, now currently the example that I show on the screen is a rather simple example. So let me turn on the draw again. So we have this I'm sorry, my draw thing is a bit rough. So this part that I highlighted is the request header. The request header. It seems that if I write in cursive, the tablet doesn't behave erratically. Okay, the header here is like the envelope, if I have to make an analogy. So this is like the envelope. Usually you put information like the address, to whom the letter is addressed on the envelope, right? Now, since this is only the envelope, there should be a body of the request, right? The actual content. The actual content can be empty, just like the request that I demonstrated using HTTPI. So the request only contain a HTTP header that specifies the path and also the host that may contain the resource addressed to that given path. And the body can be set to empty. But in another example, let's say how do I okay, mouse. Okay, yeah. Maybe I should back to this. Okay. So we can put a body in the request. So we can put a data like a JSON object in the body, or if you let me check. Okay, let's pick an example. I'm sorry, I didn't know the other example. So let's say we pick this example. In Indonesia, we have this. Well, apparently the search bar has been removed. Okay. Okay, let me choose another example. So let's say we are using a search engine, and let's say I am looking for Ira Supolia here. And I want to correlate this with this actual source code. So the input forms that you put in the web page will serve as the mechanism to receive input from user and bundle it into the request object sent to the server. So let's say if you put a search query in the input form, and then you send it. Those requests may have okay, how do I may have a payload or the data embedded in the request. If you are using GET requests, the payload usually displayed in the URL bar. So you can see that the query terms, the search query, is embedded into the URL bar because the request object sent to the server is using the GET request. And you can see there are 3 data in the body or the payload sent to the server, the query itself and the others 2, which I don't know, but these are these informations sent to the server. Now, the response also similar. So we have the headers here, the envelope, and then we also have the body. The body is the content of data sent to the client. And the content here is a JavaScript object notation or JSON object. So you can see that it comprises of 2, what is called in JavaScript object again? The first one is an array of string, and then the second one is a JavaScript object, which like similar to Python's dictionary, right? We have key and then the associated value. Okay, back to the slide. So yeah, that was about the request and response. Now the request may have several methods. So if you use the API client like HTTP or Postman, we can set the type of request object, or to put it more specific terms, we can set the request method embedded into the request object. So there are several types of request method. The common one is get and post. These 2 are the most common request method. And the pattern, well, not pattern, but rather the convention. Okay, so the convention agreed upon many developers right now is use get request if you want to retrieve a data that is not sensitive, because you have seen that if we use a get request, the data that we send will be displayed in the URL bar. So if you are submitting non-sensitive data like your search query or anything else, as long it is not a personalized identifiable information, then it is okay to use get request to send your data. However, if you have to submit data that's need to be sent in a more secure manner, then you have to use another type of request. That is post. Because post will put that data in the body of the request. And that data can be a JSON string or any other, pretty much any string can be put into the body of the request object. The question whether that body is recognized by the server is depend on whether they have the handler or the function that can process that body of data from the request object. But the pattern here, the agreed convention, is if you submitting sensitive data, or if you are asking the server to create a new entry, a new data entry, then you have to use this post method in the request object. So that's the convention agreed by many developers. Get is used to retrieve data, post is used to send data. There are other methods like put, fetch, and delete, and This will be relevant if you are developing what is called as web service or web API later on. But if you are only developing a web application, then usually get and post will be sufficient for your purposes. Okay, up to this part, any questions regarding the method of communications between two programs in the internet? No questions so far? Okay. Yeah, I already explained this before, the responses. Yeah, as about the responses, yeah, you can use API client like HTTPI or Postman that is mentioned in your latest assignment description. And you can also check it in the browser directly. So if you are using Google Chrome or Chromium or any other Chromium-based web browser, you can use the developer tools and see the network tab here. And you can choose one response. Not what response, but actually a request. So the network tab in your client, in your web browser here, is referring to the request sent by your web browser to the server. So let's say I open this Erasupaya site and check, let's say, one piece something, and you can see that in order to view all of these images of one piece characters, apparently, the web browser needs to send a request. So from the HTML page contained in the response, the web browser noticed that there is this image tag with source pointing to this URL. Something blogspot.com / blah 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 / onepiece01_lavi.png. So that's the URL. And since web browser recognized that this is an image tag, web browser will send a request to this URL, and that request can I find it? This one. Yeah, it's somewhere in the list, but yeah, the request is there. So the browser will send a request, a GET request to this URL, and the response, the server send back a response with status code 200. So the request was successfully processed by the server. And yeah, in the headers, you can see more information like the length of the image, the type of the resource contained in the response, and the type of web server. I don't know what is this. It's called Vive. Maybe it's a web server used by Google in Blogspot. I don't know. And yeah, that's what happened in your web browser. So when your web browser receives the HTML page, your web browser will make subsequent requests to every resources linked in the document, like the images or the scripts. Those will be requested by your web browser. But if the resource is a simple link in the anchor tag, your web browser will not send any request to that link in the anchor tag. So yeah, that's what happened. You can inspect the request and response using the developer tools provided in your web browser. Now we come to the format of the data. Yeah, as I mentioned before, since we are developing, well, not developing, but we are trying to make two programs communicate with each other. Both programs needs to have the common standard agreed upon both of them in order to communicate. At least we already agreed that the program, the web browser that we use, and also the Django web application that we develop and display on server agreed on the method of communication. So we use the HTTP or HTTPS protocol. So this is the communication protocol used between your web browser and your web application. Now, the remaining elements in this stack of data communication is the data format. The HTML can contain the HTML can contain other contents as well, like the CSS and also the JavaScript codes. But other than HTML, we can have other data formats, JSON and also XML, or if we want to be more general, then the data format essentially is a text, right? So any text will do. But then there's a format like HTML, JSON, and XML because we want to have a more structured approach to bundle our data when delivering it from a program to another program. Yeah, so in theory, you can just send anything. You can send any text. But then how to make your program and other program knows that the text that being sent and received among those programs can be understood and can trigger any operation within each respective program. You can define your own format, but yeah, that's it's outside the scope of this course. If you want to define your own protocol and also your own format, then you will do that in the computer network course. But in this course, let's just use the existing data format because we want to focus on learning how to develop a web application, not to define a custom data format. Okay. Right. So let me clear the drawing. So your web browser can set a request to request a HTML page, a style sheet CSS, a JPEG, a JavaScript code, or any data. Can also requesting a text file, that is also possible. But the thing to note in viewing this request response cycle is not every data is coming from existing files in the server. When your web browser requests for HTML file, CSS, JPEG, or just JavaScript file, those resources that you request from your web browser, for most of the time, already exists as files in the server. So the files are simply transmitted byte per bytes from the server to your client. However, some data or responses are generated, right? Well, it might incorporate existing file and then modify it and put it some values, like what you did in the previous tutorial. You put a variable in your template file. Tutorial. So in the tutorial, you can put a variable in name, and this name will be customized based on the code that you implement in the use. In the views, you created a dictionary called context, and then you put the result of querying all objects into a key called items. And then you also provide another key name called name, and that key is associated with other string. Let's say the other string is the key or your other name, actually, anonymous, whatever you choose. You can put the value of the name in the context dictionary. And that value will be processed by Django when Django attempted to return this wishlist page. So when you invoke the render function, the render will accept the template file, that is the wishlist.html file, and also the context dictionary. And by doing so, Django is able to put values in the variables in the template page. So the name from the context will be put here. So this name variable will be replaced to whatever name you assign it in the dictionary. And the items will be used as a collection. And that collection can be iterated in the template. So by using this syntax for loop in the template, you can use a collection type in the context dictionary and iterate each item from that collection to produce a repeated HTML text. So here it will generate a TR tag containing 3 columns whose values obtained from each item iterated from the items collection. So if your data set in your database contains 3 entries, then this for loop, this iteration will produce 3 TR tags, where each TR tag will contain the values from each iterated entry. Okay. Yeah, that's explanation about the template processing in Django. Any questions before I move to the next slide? Anyone? Any two? Nobody? Okay. Right. So I mentioned we have these formats so that we can structure our data in a more organized manner. One of them, we can use HTML format, where HTML format is used to provide structure to the information that will be displayed in the web browser. So you use text to indicate the section of your information and also to provide meaning to the content that is understood by your web browser, so that your web browser can do something to those texts. For example, if you put th and td. Both text can be used to represent a column in a table. So you may try it yourself. Let's say, I think that we can do that in the simulator. That's the Right. So there is an HTML playground here in the tutorial site. Let's see if I want to create. Then have this art and H A E. So then the art. A and E X and Y. Plus with A and B. So both TH and TD can be used to represent a column. And you can use TH again, I guess. Yep. So I can use TH again to represent a column. But if you look at examples on the internet, usually TH only used once, only in one TR, while the other TR will use TD. So when we use TH, so while both can be used to represent a column, I think I want to trigger a discussion here. When should we use TH and when should we use TD when structuring an HTML document? Because you have seen that both can be used to create a column, right? But there must be something that makes TH is more appropriate from TD and also the other way around. There must be some condition or cases where TH is better than TD and vice versa. Do you have any ideas why there are two separate texts to display a column in a table? Do you have any opinions regarding this? Or maybe some cases why there are two separate texts for displaying column in HTML. Any ideas? So yeah, let this become your, I don't know what it's called. Try to ponder this in your free time, like why TH exists and also why TD exists and why we have these two ways to create a column in HTML table. Okay, let's move on to the next slide. Okay, some explanation regarding HTML. Yeah, I'm going to skip a bit regarding the slides of HTML, but you can see in the English version that there's a bit of explanation about HTML in the tutorial site. So if you look at the guides tab here, you will see several guides, such as quick introduction to HTML. You can play around with the examples in this HTML guide. And I think it's more descriptive to try it. It's better to try it directly instead of just looking at the slides, okay? So in HTML, we will have starting tag and end tag. And between those tags, it may contain the content or the value that associated with the pair of tags. And some element may also be empty, i.e. they don't have content, and some element may only comprise of single opening tag. So the tag doesn't require any closing tag, such as PR and HR. They don't have closing tag, so you can read it just like that, just a single tag without the closing pair. And a tag can also contain attributes that will determine the behavior of your web browser when it read the text from the HTML document. And HTML and XML is similar. Both have this common root from a markup language called HTML. I forgot what it stands for, but I think it was mentioned in previous slides before. So HTML is, you can view it like a subset of XML. Okay, so each XML elements usually will have closing tag. Well, it is also possible to have a tag that doesn't have closing tag in XML. So if you, let's say, if you have coded in Java, especially if you previously taken Program Foundations 2 in this faculty, you may have seen this kind of XML file before. Let me open something. Maybe I cannot display the IDE, but I will only display a section of the document because it's a bit, what is called, this is a source code from an internal project that shouldn't be shown to the general public. Okay. So in a Java-based project, they may have this file called pom.xml that defines the dependencies. And since it is an XML document, you can see that the texts are usually having an opening and closing pair at text, but also there's an element that doesn't need a closing tag, such as this relative path element in the XML file. So yeah, but usually every element should have a closing tag if they do have a closing tag in the element. But if it doesn't have a closing tag, then it is usually enough only to put the opening tag or the closing tag of that particular element. And this XML document actually following a structure called DOM, Document Object Model. And this DOM is following this tree data structure. So if you are currently taking data structure course or maybe have taken data structure course, the HTML XML document can be viewed like a tree data structure, starting from a root element, for example, HTML, and that root element may have child. For example, in HTML, usually it will have two child, the head and the body elements. And in each child, under the hierarchy, they may have another elements as their children. And an element may also have their own children as well. So you can view it like a hierarchical data structure, like a tree. And yeah, the fact that HTML or XML is structured like a tree data structure, this fact will be used later on when you have to interact directly in manipulating or querying the elements using JavaScript. Because the lookup for elements later on by using JavaScript will be handled like performing a lookup operation in a tree data structure. If that still sounds strange to you, don't worry, we will go more into that in the week that we discuss about JavaScript. But if you already familiar with that, or if you have taken data structure course before, it's also nice to know. So that's about XML. Now we also have JSON, JavaScript Object Notation. JSON here usually favored over XML because it is more concise. If you compare XML and JSON, you can see that XML is more verbose. For defining a single element of data, you have to create the opening tag, and then you define the value, and then you write the closing tag. Contrast that to JSON. JSON, you usually only need to you only need to create or define a key attribute and then map it to another value, a string, a number, or even another JavaScript object. So it's more concise. So we can have this JSON, and the structure usually JSON begins with curly braces, and in that curly braces it can contain a list of attributes, and for each attribute it may contain a literal value like a string, an integer, a Boolean value, or the value is another JavaScript object. That object can be another object that may contain several attributes, or that object can be a list of objects or list of literal elements in the JSON string. Yeah, so XML usually more often found in old systems. So yeah, the last time I interact with XML document in context of web application development was like during my undergraduate study. So it's like, yeah, many years ago. Okay. But now people more often use JSON instead of XML. But yeah, XML is still there. Maybe not used for data communication. However, it is used for configuration. What like I just showed to you just before. It is used to configure software project. XML can also be used to configure data migration. So some tools follow another approach differently from Django's migration tool. In Django, you can invoke make migrations and migrate, right, to generate your database tables directly into the database. However, in another ecosystem, like in Java, for example, the migration tools traditionally used XML and also even SQL directly. SQL is the language used for conducting queries directly in the database. Okay, but yeah, in migration tools found in Java ecosystem, they still support XML, and the XML files are used to define the data model. So in Python, you only need to put attributes of your data as a Python class attributes in the Python code. But in another ecosystem, in another realm, in Java, some tools still using XML. So you need to, for example, define a column tag, and inside that column, you define another tag called ID, and then the name of the column, and so on. So it's still like that in some tools. JSON usually preferred because it's more concise, and especially in current technology landscape where there are so a lot of support for JavaScript-based ecosystem. So if you're really using JavaScript when building your web application in the back end and also in the front end, then JSON is like the go-to data delivery format for your applications. Okay, do I still have time? Okay, I still have some time. Okay, yeah, the code that you see in the slide here is an example of performing asynchronous operation using JavaScript. So for historic reason, web browser support on asynchronous operation is based on this XML HTTP request class in the JavaScript. So this code will execute a function when your page is the loaded web page already on ready state. So remember that your web browser will receive a response, right, from the web server containing the web page, along with any code, any CSS and also JavaScript code. And it is possible that your web browser is not finished loading the whole page. Therefore, the page might not be ready. So web browser knows the state of the page loading. So it might be still loading, and the page might have finished. And this code will only execute the function, the my function here, only if the page is ready. So everything has been loaded successfully by the web browser. It also checks for the response code whether it is successful. And if both condition is true, then this function, the my function, will be executed. And this my function here will receive a reference to the DOM, the document object model. And inside the my function, since it received a reference to the document object model, it can perform query and also manipulation towards the elements in the XML or rather HTML document. So it can, for example, retrieve every HTML text that contain attribute name equal to title. And then followed by retrieve only the first child of that tag that match with the query. And then in the next statement in the code, get a reference to element that has ID equal to demo and set the inner HTML value, i.e. referring to the HTML tag that may be put into the tag as a content as the value of the HTML tag you query from previous statement. So yeah, that's possible when using JavaScript later on. So yeah, we have this API client. So previously, remember that we are developing a web application, and that web application is accessed from a web browser. So we have two programs, like in the illustration I drew in the beginning of the lecture. But we can be more general. The program running on server can serve any kind of data theoretically. But since we are developing a web application, the data can return HTML or JSON or XML. We will stick to those three formats in this context. But the client itself doesn't have to be a web browser. The client can be a graphical-based client like HTTPI or Postman, or even Python code. Okay, so let me show something. Tutorial. So I can use this library called request. Here, a request. Yeah. HTTPS, HTTPI. Yeah. It's basically the same, right? The first one is the direct, the raw string. So you can see that this is the JSON string sent from the httpi.io/hello. And yeah, you can do that by using request library. But visually, by using a graphical user interface based client, you can also do the similar request using HTTPI. And yeah, it depends on your preference. If you like to work on terminal for most of the time, yeah, you maybe will use request library here. But if you are more comfortable using graphical based interface, then you can use HTTPI or Postman or Insomnia in order to send a request to the URL. Now, the web application that we develop can also provide an API, application programming interface. So usually, we can have a website that display the information as a web page, okay? But also we can provide a functionality that instead of returning HTML web pages, it returns a JSON or XML data. And in a way, we kind of developing a program that invokes a method in a different program, right? So when I send this request to httpi/hello, we can say that we invoke a method called hello on httpi.io's website, and that particular method produces a JSON string that is sent back to our computer, right? So it's like the cool term is RPC, remote procedure call. So we can have a procedure, which is a general term for function, method, subroutine that can be considered as procedure. we can sort of invoke the procedures that is running on different computer. So that's what remote procedure call is. And API is the mechanism that lets us to expose the functionalities in our website to be invocable, to be callable from different clients from web browser. So we can still have a Django application running, but at the same time, we also provide a URL, for example, that will return a different type of data to the client. And that's what you have been doing in the current assignment and also in the previous tutorial. So you can return the usual HTML page, but you can also return a JSON or XML data based on the requested URL. And you can do so that by mapping the particular URL to retrieve JSON or XML, right? And associate them to the corresponding function that will produce XML or JSON data. But yeah, but it is not that simple. Well, it is simple, but eventually, if we want to share the API existing in the web application, we will eventually need to document them, right? So there are several standards to enable developer to share the API of their web application. So several standards like Open API, Swagger, exist to be used as the common language for every developers to let their web application can be interacted from other application. So yeah, and the interaction happened between two applications or two programs happen through the HTTP protocol by sending a request to particular URL, and that URL will be processed by the target program, and the target program will do some computation and return back the result as response back to the requester, which is another program. And this will be your main focus later on when we have entered the post-midterm period where we develop mobile application. Because you will need to provide API in your web application, or we could say you need to provide the API to your back end of your application so that the front end, i.e. the Flutter or mobile application, can get and or store data from the back end. Okay, yeah, I think that's enough for today. Yeah, the code for marking your attendance is, let me open Scale first. Okay. So the code is apparently I cannot. Yeah, this one. The code is A08NB5, all lowercase. So that's for today. Any questions before we end the lecture session? Or any remarks or feedbacks or questions? No question? Okay, thank you, Matthew. Okay, if there is no questions, I think we can end the class now. So don't forget to continue work on your assignment. And yeah, I think that's enough for today. So thank you, everyone. I will see you in the lab in this coming Thursday. So thank you. Bye-bye.
Thank you so much, sir.
Yeah.
Sorry, I didn't see the code.
Okay, let me open it again. Thank you. AO8ND5.
Okay, thank you.
No worries. Okay, has everyone copy pasted the code or noted the code? If everyone has noted the code, I'm going to end the Zoom session. So thank you everyone. Bye bye.
Thank you, sir.